Hi guys, this is Miss Pruitt again with another video on the basics of trig functions, graphs. This time we're going to talk about amplitude, zeros, and the period. But we are still talking, or in this video I'm still talking about sine of x. So let's get started. I've already plotted sine of x, and I want to talk about amplitude. All right, so we find the graph's amplitude, which is denoted like this, as taking 1/2 of the maximum of the graph and subtracting it from the lowest part of the graph, or the minimum. So in this case, looking at, again, sorry, this is y equals sine of x. I always seem to do that. Y equals sine of x. In order for us to find our amplitude, it's going to be 1/2 times the maximum height of the graph. Well, my maximum height is 1. And the minimum height of my graph, right, my min. So it's going to be minus -1. Well, you guys, remember, 2 negatives make a positive. So this is the same thing as 1/2 of 2, which of course is just 1. So the amplitude of this graph is 1. And what that is, and what that means is, it is the height . The height of my function up from the x-axis. This is our amplitude. And just how we solved for 1, I can clearly see from my graph that this height from here to here is 1. So that's amplitude. All right, you guys, so let's now talk about the period. The period is going to be the distance, the horizontal distance that our graph follows until its pattern repeats itself. At what horizontal distance does the cycle repeats? So let's say I'm starting at 0 and I'm following along on my graph. My graph goes up, goes down, and then it starts back there. Can make it a little thicker. Going up, going down, and going back up. It's from there that my graph repeats the same pattern. Not only going or continuing going in the positive x direction, but also in my negative x direction. So the question is, how far do we go? So we're going along until my graph just starts repeating itself. Well, I'm going to say this distance here, and I see that my number has been covered up. This was a 2 right here. So the distance that my graph goes horizontally until it repeats itself, it's going to be from here to here. And this distance is 2 pi. Whoops. 2 pi. And that is the period of the graph. It's at every 2 pi, at every distance of 2 pi, this graph is going to repeat itself. It's going to repeat itself there, there, here, and it's going to do it forever and ever and ever. So that's how you find your period. You start at 0, and you continue on horizontally to see how far your graph goes until it repeats itself. Alright, so I'm good because I have my amplitude and I have my period. Last but not least, I want to find out where my zeros are. By the way, you guys, zeros are the same thing as x-intercepts. And an x-intercept is wherever your graph crosses the x-axis. So if I'm looking at my graph, I notice that my graph is going to cross the x-axis there, here, 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 there, here, and here. And what I'm going to try to do is see if I see a pattern. To me, it looks like there's the same distance. It's like the same distance in between all of these zeros or x-intercepts. So if I'm starting at 0, I know that I have a 0 or an x-intercept at 0. There's also one at pi. There's one at 2 pi. If I'm going backwards, there was one at negative pi. There's one at negative 2 pi. There's one at negative 3 pi. 3 pi, 4 pi, 5 pi. Do we see a pattern yet? It looks like there's going to be an x-intercept at every single pi interval where I have an integer in front of it. An integer, in this case, is going to be a whole number. It's going to be positive or negative. So that means 1, 2, 3, 4, 5, 6, 7, negative 2, negative 15, positive 36,643. It doesn't matter. As long as it's a whole number in front of pi, I'm going to have an x-intercept or a 0 there. So we don't have time to write all those different numbers. We're going to use a letter or a variable to represent all of those numbers that we can plug in. So we're going to use k. And all that k is an integer. It is a positive or negative whole number. So k, which could be 1, negative 15, or negative 3,000. K is going to sum all that up for us so we don't have to write all of those different answers for my zeros. So my zeros for the sine graph is k pi. So just to make it all nice and neat, I'm going to put that my zeros are located at plus or minus k pi.